Hello class, today we're beginning chapter 4, and as we turn to lesson 1, we're met here with a rather odd speed limit sign that says 12.5 miles per hour. Now it's rather odd because we never see a half mile being posted on a sign like this. We normally see numbers, whole numbers such as 55 or maybe 40 or 25. So to see 12.5 miles per hour is a bit odd. And now the purpose of this is to introduce us to rational numbers. So let's start here on page 150, and we read, "This sign was put up along a road near the Fresno airport after it was discovered that many drivers were not slowing down as much as they should." So now we're beginning to see maybe a reason. It says here, "The fact that the number on the sign is not an integer has proved very effective in getting people to pay attention to it. The number 12.5 is an example of a rational number." Now we've dealt with integers, but we're going to now delve into the more broader definition of numbers, because we're going to not just deal with whole numbers as we were, as integers. We're going to now talk about integers as any numbers that can be written as the quotient of two integers. So the number 12.5 is rational because it can be written as 25 divided by 2. So we have the number 12.5, and we can write this as 25 divided by 2. Okay, so we have a fraction here. In fact, a mixed fraction. This is a fraction here. We have the mix as a number plus the fraction. So we can convert that easily into a fraction. And doing the division indicated by this quotient, if we were to divide 2 into 25, and we'll do this the old-fashioned method, right? We go 2 into 2, that goes once, times 2. And now we have 0 as a remainder. So then we'll go ahead and bring down the 5, and that goes in 2 times. We'll run out of room here. We'll subtract 4 from the 5, and now we need to go into the decimal. All right, so we'll put a decimal there. We'll put a decimal up here, and we'll bring down a 0, and we'll end up with a decimal as an answer. 2 into 10 goes 5 times, and now we have 12.5, which we knew that we could have done it directly from here. We know that a half can be represented as 0.5, but obviously not all numbers are as simple, and we will, as we move on in math, we'll be dealing with numbers of different decimals that cannot necessarily be so easily interpreted from a fraction into a decimal. Now, written this way, it is said to be in decimal form. Okay, now rational numbers written as fractions can always be changed to decimal form by carrying out the indicated division. Here's another example. We have changed the rational number 3/8 to decimal form. So we have 3/8, and if we did the same thing as we had there, we can have 3 over 8. Well, we would put the 8 on the outside of the division bar, right? And put the 3 inside, and we would start doing, again, our division as they do there. And our answer would be 0.375. Without going into all the tedious math, we know that was the answer. Dividing 8 into 3, as shown on the right, we'll get 0.375. Every integer is a rational number because every integer can be written as the quotient of itself in 1. So you're going to say, well, what about 5? Okay, well, 5 can be written as 5 over 1. So these are integers. Now notice each of these being integers. We've already learned about integers in the previous lesson or in the previous chapter. And that's what we have here. We just have many integers that are just simply being divided. We can write them. When we say as a quotient, we know we can write things as a quotient. So in other words, we could say 5 divided by 1, but we're not doing that anymore, are we? We're writing them as fractions, okay? So That's the way that we like to write them because it'll give us the opportunity to do many wonderful things further down the road. -2 is a rational number because you can write that as a form of -2 can be written as -2/1. In fact, we learned that we can also write that as 2 over -1, right? And they would both end up as -2. And these are both sets of integers. Okay. Rational numbers, like integers, can be represented by points on a number line. The number 2 1/2, for example, is located halfway between 12 and 13 on the number line. So if we look at the number line they've provided, we have 10, 11, 12, 13, 14, 15, and you see the arrows. So it basically just this isn't the complete number line, obviously, and the arrows show us that we're just simply in this part of the number line, and we can go right in between 12 and 13, and we know the exact point right in that number line, 12 1/2. There's a point that we can locate. Now, we can also go and look at these other examples. In fact, I have the board here. I have our number line. And it says several other examples of rational numbers on the number line are shown in the figure below. So we have -3.5. Now, -3.5 means I need to go out to 3 and add another 5. Excuse me, a 0.5 or a half. So that would be right about here, right in the middle. Right, so somewhere in here. It's probably not as good as they are. And we know that that could be located right between a -3 and a -4, and that's -3.5. Now, how about -1/4? Well, -1/4 would be half of half the distance between 0 and -1. -1/4. So this would be -1/2. So if I just kind of come in between and say, well, it's right about there. I think I did a pretty good job there. Probably a little better than the last one, huh? And then I can indicate that as -1/4. And if we go over, we could also note 2.1. Now, 2.1 is not a fraction, but we can convert that into a fraction. 2.1 would be the same as 2 1/10, would it not? So we have 2.1. So we're looking at 1/10. Just think of 0.1, 0.2, 0.3, all the way 0.9, and then the 3, right? So we would be at 1/10, but puts us a lot closer to the number 2. In fact, if you look where they put their point, it's just right next to it. So let's just follow what they did. So, and again, I mean, there is an exact point there. We can just sort of estimate it on our number line. If you were to measure, we could certainly measure. And let's look at the last one, is 4 1/3. Okay. Now 1/3, when we write that as a decimal, we have a little bit of a problem, don't we? Because we know that 1/3 is 0.333, and it never ends, right? It's a never ending. You couldn't really define 1/3 completely just writing numbers, because this just continues, and we'll learn how to do that. You can put a dot dot dot, or you can put a line over the 3. But anyway, on a number line, we know that it's exactly 1/3. In fact, if you took a piece of paper and folded it perfectly into thirds, you could find the line that is 1/3, right? So it's somewhere roughly around here. Oop, no, that's probably more like a quarter. Let's get better with this, huh? All right, so if this is a half, it's not quite halfway between the half and 3, because that would be 1/4. 1/4 would be there, so that's why I'm moving it over probably closer to here, okay? And that's probably not as accurate as it should be. Oh, I'm sorry. I'm over at 3 1/3. Let's move over. Sorry, the teacher's adding numbers to the problems. Let's go 1/3. This one probably going to be around there. And again, it's probably closer to a quarter, but we get the picture here. And primarily that it's between 4 and 5, and it would be 1/3 if you were to take this and break this into thirds. Let's say 1, 2, 3. That would be the first third. This would be the second third. So now we're asked in our example problems, which number is larger -3 or 2.1. So we're looking at these numbers that we've placed, and -3.5, rather, it's right down here, all the way over here, versus 2.1. Well, we already know that this is the larger number, 2.1, simply because it's to the right of -3.5. Now, we read here, it says, we could have answered this question without finding the numbers on a line by reasoning that because all positive numbers are on the right, okay, all the positive numbers are up here going this way. We know all the positive numbers are on the right and all negative numbers are to the left, and every positive number is larger than every negative number, okay? Let's take a look at example number 3. Which number is larger, -1/4 or -4? Now, -4 is way out here, right? This is -4. I'm going to go up into the number line, and we already pointed out over here that -1/4. So -1/4 or -4, the answer would be -1/4. Okay, 1/4 is to the right, so we would write that as they write it, as -1/4 is greater than -4. Okay, so some of this we've already done in exercises with integers. Now we're getting into fractional or the decimal portion of math, and so it's just a matter of finding ourselves within, but we're still going to apply the same principle. Which one's larger and which one's smaller? Well, which one's to the right and to the left? Okay, so that is the end of this lesson, and we'll move on to our exercises.